In this video, we learn about solving ODEs with homogeneous coefficients. A differential equation of the form m of xy dx plus n of xy dy is equal to 0 is homogeneous if m of xy and n of xy are both homogeneous functions of the same degree. Solution procedures. To solve homogeneous equations, we use the following substitution. 1. We let y to be equal to xv. Then we now differentiate y, right? So we are going to apply the product rule in this case. And so we are going to have dy dx is equal to, so we are going to keep x, then we differentiate v, plus we now keep v, then we differentiate x. So now let's see. Let's keep v. When you differentiate x with respect to x, you are going to have 1, then plus you now keep x, then you differentiate v, so that will be dv dx. This simplifies to v plus x dv dx. Thus, to solve a homogeneous differential equation, we use these two substitutions. With our first question, we have to solve the differential equation x squared plus y squared dx minus 2xy dy is equal to 0. And so here we have to identify our m and our n functions. So m of xy will be equal to, so now the m function is the y attached to the dx. And so in this case, this is going to be our m function. So we are going to have m to be x squared plus y squared. And our n of xy function is the one attached to the dy. Thus, we are going to have our n of xy to be equal to minus 2xy. Now let's verify if these guys are homogeneous. So let's find m of lambda x, lambda y. So that would be lambda x squared plus lambda y squared. So that's going to be lambda squared out, x squared plus y squared. Now let's compute n of lambda x, lambda y. And so that's going to give us minus 2, then lambda x times lambda y. And so you're going to have minus 2 lambda squared xy. Thus, you're going to have lambda squared out minus 2 xy. Hence, we have lambda squared, then n of xy. And also for the m, you're going to have lambda squared m of xy. Since m of xy and n of xy are homogeneous of the same degree, thus we have the degree to be 2, we make the following substitutions. So y is now giving us v times x, and dy dx is giving us v plus x dv dx. So now let's find dy. So dy will be giving us, that's we are going to multiply through by dx. So you're going to have v dx plus x dv. Now in our given differential equation, wherever we see y, we are going to write v times x. And wherever we see dy, we are going to write v dx plus x dv. Thus, you're going to have x squared plus y squared, but y is now vx, so you're going to have vx all squared dx minus 2x, but y is now giving us vx, then times dy, but dy is giving us v dx plus x dv is equal to 0. Now let's simplify. So you're going to have x squared plus v squared x squared dx minus 2x squared v, then v dx plus x dv is equal to 0. Simplifying this expression gives x squared out 1 plus v squared dx. So for this term, we are going to distribute minus 2x squared v, so this will multiply that and this will also multiply that. Thus, we are going to have minus 2x squared v squared dx, then minus 2x cubed v dv is equal to 0. We now group like terms. That's all those terms with the x and all those terms with the v. So we have the x, the x. So we are going to factor x squared from this guy, and also here we have the v, so we can move this guy to the right hand side. Thus we have x squared out, then we will have 1 plus v squared minus 2v squared, then the x is equal to 2x cubed v dv. Simplifying this expression gives x squared, then 1 minus v squared dx. 1 minus v squared because we are going to have v squared minus 2v squared, so that's going to give us minus v squared, is equal to 2x cubed v dv. Our next step is to separate terms, so we are going to have x squared dx divided by 2x cubed is equal to v dv divided by 1 minus v squared. Simplifying this gives dx on 2x is equal to v on 1 minus v squared dv. So we now have to integrate both sides. So we are going to integrate the left hand side with respect to x. So that will be integral of dx on 2x is equal to, then we integrate the right hand side with respect to v. So that's going to give us v on 1 minus v squared dv. For the left hand side, we are going to have 1 on 2 out, integral of 1 on x dx is equal to the integral of v 1 on v squared dv. So that's 1 on 2 ln of the absolute of x. For the right hand side integral, we are going to use u substitution, right? So you let u to be equal to 1 minus v squared, then you substitute. So doing so, you are going to have minus 1 on 2 ln of 1 minus v squared, then plus a constant c. Multiplying through by 2 gives ln of x is equal to minus ln of 1 minus v squared plus 2c, which is still a constant, so you can write c. So since we have all these functions to be in the form of natural log functions, it's better we write c in the form of natural log. So that's, we are going to have ln of x is equal to minus ln of 1 minus v squared plus ln of c, because ln of c is still a constant. By the rules of natural log, we are going to have ln of x is equal to ln of c minus ln of 1 minus v squared. So the right hand side will be giving us ln of c on 1 minus v squared. We take exponents on both sides, so we are going to have x is equal to c on 1 minus v squared. But y is equal to vx, so which implies that v is equal to y on x. And so our final answer will be giving us x is equal to c on 1 minus v squared, which is now y on x all squared. Simplifying this gives x minus y squared on x is equal to c. So we can now multiply both sides by x. That's going to give us x squared minus y squared is equal to cx. And so this is our general solution to question number 1. With our second question, we have to solve the differential equation x dy minus y dx minus square root of x squared minus y squared dx is equal to 0. First of all, we need to verify if this given differential equation is homogeneous. So now let's find our m of xy. So m of xy is the function attached to the dx. So here we have dx dx. So we are going to have our m of xy giving us minus y minus square root of x squared minus y squared, and our function n of xy is the one attached to the y, so that will be x in this case. So we are going to have it to be x. Our next step is to verify if m and n are homogeneous and if they have the same degree or not. Thus we have m of lambda x lambda y is giving us minus lambda y minus the square roots of lambda x all squared minus lambda y all squared. So you're going to have minus lambda y minus lambda squared out x squared minus y squared all square roots. And so we are going to have minus lambda y minus lambda square roots of x squared minus y squared. So we can factor out lambda, so that's lambda out, then minus y minus square roots of x squared minus y squared. Thus we have lambda out, then m of x, y. And so this is homogeneous of degree 1. Now let's verify if n is also homogeneous. So we are going to have n of lambda x lambda y is equal to lambda x. So that's lambda times n of xy. Thus n is also homogeneous with degree 1. Since m and n are homogeneous of the same degree, we are going to use the substitution y is equal to vx and dy is equal to v dx plus x dv. Thus our differential equation will be transformed to x. Now dy is now giving us v dx plus x dv, then minus y, but y is now giving us vx times dx minus the square roots of x squared minus y squared, which is now v squared x squared, then dx is equal to 0. So we now simplify this guy. Thus we're going to have xv dx plus x squared dv minus vx dx, then minus x squared minus v squared x squared dx is equal to 0. Now let's simplify this expression. Now for the first term we have xv dx, then here is minus vx dx, and so these guys are going to cancel out, so this will cancel out that. So we are going to have x squared dv, then minus square root of x squared minus v squared x squared dx is equal to 0. With this term also we can factor out x squared, and so factoring out x squared we are going to have x squared dv minus square root of x squared, then 1 minus v squared dx is equal to 0. Thus we are going to have x squared dv minus x square root of 1 minus v squared dx is equal to 0. Separating terms gives dv on the square root of 1 minus v squared, then minus x on x squared dx is equal to 0. Thus this simplifies to dv on square root of 1 minus v squared is equal to 1 on x dx. We now integrate both sides, and so we are going to have integral of 1 on square root of 1 minus v squared dv is equal to integral of 1 on x dx. The integral on the left hand side is an identity, so the integral is giving us sine inverse of v. So this is going to be sine inverse of v is equal to, the integral on the right hand side is ln of the absolute of x plus a constant c. So thus we're going to have sine inverse of v is equal to ln of x plus ln of c, because ln of c is still the constant. Thus we're going to have sine inverse of v is equal to ln of x times c. But v is equal to y on x, and so you're going to have sine inverse of y on x is equal to ln of x times c. We now take exponent on both sides, so that's going to give us xc is equal to e exponent sine inverse of y on x. Thus we have our general solution given below.